I wasn't. Okay, thank you. So Rolf at the Chattanooga meeting made a reading of his proposal, and in his proposal there were the introduction of split types. So we discussed the split type issue in the working group during the past couple of weeks. We've been organizing teleconferences and also exchanging emails. So what is the current situation? So in the initial presentation I made in Portland in 2017, I proposed to add a new predefined value for the split type argument. What you see right now are the original slides I presented in Portland. So at that time, the new type value was called MPI com type physical topology, or any suitable names, and they were property of the newly created communicator. So at that time, the only way of creating new communicators was by using this name. And the point I wanted to stress at that time was that there were no names for communicators. So communicators were created recursively. So you split a top communicator into subcommunicators, and then those subcommunicators can be split again into new subcommunicators. So it works well for hierarchical nodes and hierarchical machines. So the two key points for us at that time was that it was independent from the hierarchy depth, and no fixed name were used for communicators. So that was the initial presentation I made almost 2 years ago. So in the COM-split type, there is this argument split type that can yield different communicators, even if the same value is used. And currently only one value is defined, which is MPI com type shared. It is used for creating shared memory regions between processes, so that you can use a different programming paradigm if you want between those processes. And also implementations are free to define their own types if they wish. So what we discussed in the working group so far. So we propose to introduce a new single value to allow for hardware-based hierarchical splitting of the input communicator. So the current name has changed. It's not fixed, but currently it's something like MPI com type hardware domain or hardware level. But I don't think the name is that important. It is in the end, but the principle is important, not the name. And so far, there was a consensus in the working group about defining only a single value. Also, an info string can be used to split at a specific level resource. Those info strings would be implementation dependent, and they can be provided by the runtime system, the topology discovery mechanism, the process manager, whatever piece of software you need to achieve that. And the important thing is that the way to access and use those info strings should be standardized. The names are not that important. It's the way you use them that matters. I think that's an important point. About the naming of resources. Resource names could be new split type values. So instead of defining only one value, we would define a bunch of new values, such as MPI com type socket, MPI com type NUMA, MPI com type core, etc. However, I think that this approach is totally not standard friendly. What about new names? It's already the case for Intel. We probably will have in the future a tile level, a die level, maybe more levels. So if we start to do things this way, I think it's a very slippery road, because we will end up by standardizing, going back to the forum every couple of months or so to introduce new names. What about the names that are changing? For instance, the name socket is not recommended anymore by IBM and Intel. So if we want to standardize, for instance, an MPI com type socket name, this name is already outdated. There is one possibility about the standardization. It would be to standardize not the names but naming rules. And it's an idea that was proposed by Atsushi Hori for the base types in MPI. He proposed to, in order for the standard to be more reactive and to be more in line with the new base type names, to standardize new rules, so that we would, when the new names appear, we would automatically add the new name to the standard. So maybe that's the way to go, I don't know. It's not standard friendly. The same name can have different meanings on different hardware. Different names can be used to designate something which is similar on different hardware too. And I think that full portability will never be achieved. However, I think that even if portability is not fully achieved, I think that the changes that would be required to the application should be kept minimal. Also, defining only a subset of resources, for instance, common defining names for resources that are common to all architectures is not a good idea to me either. We will need to find an agreement about these common levels across architectures, and some of the above problems still apply. So what is done currently in different implementations? So in the HSplit library, which implements the proposal in the large sense that we made so far, we define only a new split type value, which is MPI com type hardware domain, and we also use an info key value, which is MPI hardware domain type. So if this info key value is not defined, then the hierarchical splitting of the input communicator is achieved. So it is this recursive splitting. It's possible until the bottom of the hierarchy is reached. So in that case, the outcome is MPI com null. And subcommunicators are strictly smaller than the parent com. So you have a couple of rules that are listed on this slide. It's made to avoid redundancies in the case of levels that are the same. If the key value is defined, then we split at the given level, at the level specified by the name, as a value to the MPI hardware domain type info key. In the current implementation, we use HWLock names, we use netlock names for intranode splitting, and names for netlock or custom name for the network. This current implementation doesn't make any assumption about the process mapping and byting to resources, but we are able to handle weird cases. I mean, by weird, I mean heterogeneous binding policy among processes. So if you want to do weird things like that, it's okay. It supports this kind of stuff. And also, it supports heterogeneous nodes. It doesn't make any assumption about the nodes. They don't need to be all the same. Also, HSplit currently defines query functions to access available names. For instance, we have this function. The name is not the interface is not might change. It's not. I mean, the interface is important, but not that important. It's once again the principle that is important. So we would have a function that the user could call in order to get an array of names, of available names of resources that he can toy with. It's pretty much it would be something in the line of MPI get processor name, but instead it would give you names of resources. We still need to work on this part, but I think the principle is important. So the user calls this function and gets names. The user use the name it wants to do the splitting, and then the user gets a corresponding communicator and can use it. So how things are done in OpenMPI? An OpenMPI follows a different route. OpenMPI defines a lot of split type values. And basically, you have a list of maybe 15 different type values. So I listed a couple of them here, but there are more of them. Those value names are also derived from HWLock resource types. And it's an important point to stress is that those types are already outdated. They are not in line with the current names defined in HWLock. So the problem that I was emphasizing about the issue of outdated names applies for this for the current implementation of OpenMPI. And I don't know if InfoString or KeyVal are used in OpenMPI. I don't think so, but I'm not 100% sure. In MPitch, MPitch follows more or less the same approach as in HSplit. It's a single new split type value is defined, MPI X com type neighborhood, and then just to indicate that you're going to split and you want to obtain a communicator that is a neighborhood based on hardware considerations, then info strings are used to guide the splitting. So an info string has to be passed. That's the difference with a split, where in a split you're not you can have a mode where you not necessarily provide an info string. That's the hierarchical splitting I was speaking before. And for the intranode splitting, it's based also on SWLock names. So why are we talking of this today? So Rolf in Chattanooga made a reading and raised this issue again. In particular, there is a MPI cart ML multi-level create from type function that relies on resources names as split type values. In his reading, there were dependencies on either our own hierarchical communicator proposal, because he proposed to use a name for the single type value, or to use split type values defined à la OpenMPI. So a bunch of new values that would be standardized. In a recent email, he also proposed to align the definition of split type values with OpenMP OMP places. And I'm not sure it's a very good idea, but we can discuss about that. However, I think that the current approach that has been taken by HSplit or MPitch seems compatible with what Rolf wants to do. That means a definition of a single split type value, the use of info string KeyVals instead of split type values, and then remove the MPI cart multi-level create from types function altogether from the proposal and use only the MPI cart multi-level create from comms. So it's going to be a little bit longer to achieve the same. You will need to call more functions, but you would be able to do the same result. So last week we had a teleconference of the working group, and the people that were present were in line with this idea of single key type value, and then maybe use info strings or KeyVals to guide to provide information to the implementation in order to have the splitting that the user really wants. So that's my slides. I've been very quick so that we have some room for discussion. So if you have questions, if somebody wants to raise a question or to make a remark about what I presented, I'd be happy to take your questions now.
Only a remark to the last slide 11. Of course, this MPI cart ML create from types can be modified by providing instead of split types, providing such strings, for example, and then it's the call is same as symbol as in the moment. The only thing what I see here is that then there must be also a string that should be standardized, providing the shared memory. It means that you can also do the shared memory through such an info handle instead of doing it with the standardized split type. That would be helpful.
I mean, okay, to have the string, a string also. You mean
to have also a standardized string that provides exactly the same functionality as in the moment the split type MPI com type shared.
Yes, but we here the key point, Rolf, is that we don't want to standardize the strings. we want the strings to be implementation dependent. The implementations are free to define their own string. So in that case, that would be the responsibility of the implementation to provide this stuff. We don't want to standardize any strings, actually. We only want to standardize the fact that you have to use info string and how to get those info strings with a call that would give you the set of info strings, of names, sorry. But the names themselves, we don't want to standardize them. That's the whole point. I mean, if we standardize the info strings instead of the key of the split type values, it's just displacing the problem. It's putting the issue at another to another place, but it doesn't solve the problem we want to address now.
For this, I have in principle the principal comment that standardization is there, that you can program according to a standardized interface. What you in the moment absolutely propose is an absolute backdoor of non-standardization. And I would say we have done in the past already successful standardized keywords, for example. We have standardized that MPI exec is using the parameter -n for defining how many processes. And we have not given, we in that case we say that if a feature is there, then exactly this name should be used. This means, for example, for HWLog, if keywords from HWLog are there, then the keywords, then the values, these names, must be according to that rule. For example, that we do not have one implementation that is doing, what is the name, HWLog object underscore core, and the other one is doing HWLog underscore hardware type underscore core. Because when they are coming from HWLog, always the same naming principle should be used. And what we did in the past is that we defined advice to implementers, a high quality MPI implementation is doing this and that. And we have about 20 locations in the MPI standard using exactly this type of wording. A high quality implementation has to do this or that. And we can do it with the HWLog names. We can use it with the OpenMP names. And maybe there are other providers of such splitting methods. And we can also say, okay, when you are providing these methods, then please do it in that way. And I would say, and especially for exactly one split type, this is part of the MPI standard. That is MPI-COM split type. We can define for MPI-COM split type if you are using this, what was it, the HW, not HW, yes, the HW, how did you name it, hardware, no. Moment, please. If you're doing it with this, how do I have it? Moment. With this MPI-COM type HW domain, and yes, together with the key value.
Yes.
That's a little bit different, the key values. That's MPI HW domain type. That then exactly one value name is explicitly specified, and the functionality should be identical to what you are doing with the MPI com type shared, and that's helpful because then interfaces can choose. Okay, we are doing all through the info handle, and we are not doing a mixed interface. We are doing one with a shared memory, because there we know that we have the shared memory quality, and all the rest below we are doing with info handles. That would be really helpful.
I don't know if it's possible to tie our definition in MPI to stuff that is done outside of MPI. I mean, for instance, having a dependency of our own names to what OpenMP does or what HWLog provides. I don't know.
But we have the freedom. We are the standardization committee. If you are looking at MPI exec specifies, okay, if this functionality is provided, then exactly those parameters those names, argument names, must be used, but it does not define that they must be there. The same for the info keys for buffering in I/O. The same for the info keys for file striping in MPI I/O, in parallel I/O. This means we have there a few standardized info keys, and we have additionally the freedom to define any other.
Okay.
And it's sometimes done with the wording. If this functionality is there, then exactly this name must be used.
So I personally think that may be a doable route, but I'm kind of with Guillaume on tying us to external standards. Using names from external standards, then we are basically at the mercy. If they decide to change something, then we have an inconsistent MPI standard. It takes us a year or two to fix this. Right?
No, we would not write the name list of HWLog into the MPI standard. We would do in maximum one example. And we say, okay, when you provide HWLog keywords, then you must do it according to this naming rule.
Yeah, and what happens if HWLog, since this is not a real standard, changes the name?
Yes, exactly.
You mean not changing the name, you mean changing the complete naming rule. This means HWLog has somehow now a naming rule like HWLog object core, and it changes into instead of HWLog, it changes into WH and core or whatever, or only object.
And then you don't know if your MPI matches the hardware log implementation that you're using in a particular system. I think if we want to do this, we need to actually pick MPI names and define them properly.
So how is that different from the CVARs and PVARs, where you get a list of them, you look through the list, you find one that you feel like using, and you use it, right? If some tool then later changes its mind about what that should be called, then my program that goes looking for the name that I thought was there is now not going to work because it's not going to find that name.
That's correct. But we explicitly stated in the standard that it's the case.
Right. So I thought that was the idea here, is that the reason for not specifying them in the standard at all is because they will be provided by some external provider. What we provide instead is a mechanism for finding out what names are current.
Exactly. That's my point. That's what I want to do. I don't want to standardize the name, but the way to access them.
Yes. So I think in addition to that, I can sort of see what Rob is saying here, that what we should have a mechanism to find out which names are available, and that will give us the HWLock names and whatever else is available, right? Whatever this MPI library is capable of understanding. And in addition to that, I don't really see any reason against standardizing a single name, which is an MPI underscore split type shared name, string, right? Which is the one that matches the thing that's already in MPI. So if I have multiple sources of where I'm going to get these names from, right? I have HWLock and I have random other thing that does the same sort of idea, right? My OpenMP places, for example. So I ask, give me all of the hardware names that you know about as an MPI library, right? And it will give me a combined list which will include all of the HWLock ones, all of the OpenMP places ones, and all of the standardized MPI ones, which is the MPI type split type shared thing, right? It will always give me the standardized MPI one because it's an MPI library, so it always knows about that one.
Yeah.
Right. So this function will always return me at least one name, that name, right? And it might also return me a longer list which includes other, names that it got from some other things that it's built in with. Great. I see no problem with that.
Okay. Can you see my slide? Can you still see my slide? So
Yeah.
that's why that's what I awkwardly wanted to explain with my MPI get hardware names. That's basically this ID. So you will get a list of names, and the user would go through this list and take the names it wants, and then use it. And so that you have a standardized way to access the name. You have a standard way to use the names, but the names themselves are not standardized. And,
yes, I'm agreeing with you, and I'm then going one step further and saying I also agree with Rolf's point about the MPI split type shared thing. That could be one of the names that's returned by this function.
Okay.
I think as an addition, I would say that it would be helpful to have the category or the source of the name returned here as well. I think this interface needs work because this isn't going to. We tried a char star style thing as well in sessions, and it doesn't fly. But as part of that change, I would suggest having a category or a source or something like that, so that I can tell this name is an HWLock name, this name is an OpenMP places name, this name is an MPI standard name, this name is a something else name, right? Where did it come from? And then the one list that you get from here identifies, well, there's several different places I got names from. Here are all the names.
So here, Christoph, do you mean by origins of these different places that you want a specific categorization in the standard, or did you want to do it maybe by a naming scheme, for example, like in the predictable network interface from the kernel, whatever, where you can tell exactly by the name what it is?
Yeah, I mean, I just mean something that identifies that if I got two names, George and Henry, back from this thing as things that identify bits of hardware, that I also get back to other strings associated with those that tell me where those names came from. And I wouldn't expect those to be standardized names. I would expect them to just be different to each other so that I can tell the difference. They might line up with things like HWLock or OpenMP or MPI, right? That would be very helpful because then I could identify, I could interpret those characters as being meaningful. That would be very helpful, but I'm not saying that we should list them in the standard because that would be silly.
Yeah, I think listing them in the standard now is a bit tricky. And but having the interface allows us in a later point to define something if we see there also something coming up, which is common in the implementations maybe.
Yeah. So the only thing that you could possibly define there would be that MPI is one of those categories. And then within that category, the only thing that we know about is the MPI com type split shared string, because that's the one that the MPI standardizes. And we're with the MPI standards committee, so we know which ones we've standardized. that's fine. The category exists, and this one example in that category exists, but there are no others because we've not standardized any others. We can't then standardize other category names because we don't know what the MPI library will be built with. We know that OpenMPI uses HWLock, but we don't know that it always will, and we don't know that all MPI libraries will. So we can't standardize that and say that this is always going to be a category name, because that doesn't make any sense.
But there could still be an argument for adding more if you wanted to, right? I mean, the shared one is kind of the obvious one, since we have a proper definition, a standard, we're using it, but we could well add other ones later on if we find a proper definition within the standard.
Yes.
Yeah.
Yes, and MPI might choose to do that in the two different ways. One is to add a string that can be used as an info value, and also to add the MPI com type split,
Correct.
actual symbol into the interface. That
Okay.
would be helpful to have both things, both routes.
Yes. And but I still have a problem with too much freedom, because when I'm looking exactly on this slide, the user calls this function and get names.
Yeah.
The user use the desired name to do this split. This means the user is a human being. And now let's look that we write software. And how can the software do decisions based on names without any meaning?
Config files.
Well, if somebody uses a name, it's because it has a meaning to them. They are not using name at random. I mean, at some point, I mean, that's what I was. That's why I was writing. We will never achieve full portability here, because at some point we need the user input about that. At some point.
But
Yes,
what about
but
adding maybe something in the standard that there's a note to the implementers that they have to document the provided keys for the user?
So one thing I've been told was that maybe we could. There are some. I don't know if it was for the tools, but there is inside the document where you have some variable names that are defined or stuff like that. Maybe it's something that we could do. We could have a side document with rules or with predefined names. I don't know exactly, but maybe it's a way to go. I don't know.
That's the same as with the variables in MPIT. The idea is too, we have total freedom now, and once we see something establishes itself and we have agreement in the community, then we can start adding them to the standard. The same thing would happen here, I would assume.
Mm-hmm.
So that's basically what you are doing with the tools, right?
Yep.
Okay.
Yeah.
It's the same idea, right? Well, once we know that something works and people using it and it's common practice, then we know what it is. We can define something and then we can put it in the standard.
So in the meantime, you would write your code so that it read in a config file, and when I port my code from one place to another, and things like the name of my NUMA regions changes, the hardware name that I'm trying to split on changes, I would simply write a different string in there, because I would run a simple program that listed all the names, printed them out on the screen. The user would intelligently choose one or more of those and try it out to see which thing works best, then write that into the config file and run their program.
That sounds reasonable to me.
Yeah, that's yeah, I agree with that.
One question. So we have interactions also with the OpenMP standard at this point here. So because I see always we have the shared memory model also in MPI, so it could make sense to have an exchange there about the naming scheme then maybe later on.
So again, I think that this proposal is not suggesting to list any of the names that OpenMP may or may not wish to standardize or suggest.
Mhm.
But this function potentially would return from OpenMP the list of names that is currently active, or that MPI is going to actually know how to deal with, because it knows something about the OpenMP that is currently active. So I don't think there is an interaction with the OpenMP. There is a sort of soft dependency, as in if OpenMP changes its mind about things, MPI implementations might well pick up the new names and return them in this function. But that isn't a dependency between the two standards. That's that's an implementation choice to update to that or not.
Yeah, I was not exactly meaning the same names. I was just thinking about that there should be an exchange, in my opinion, about the discussions how to do things here maybe for the future. So that we are in contact and not that everybody else is going different directions maybe here, because the programming model, the underlying, is the same in the shared memory area. And this could confuse then maybe the users later on in the hybrid programming case or whatever. Clearly for MPI, we have more to do here because we are not only shared memory. So we have more layers to be considered, and also not only layered models, but also graphs in this case, I guess.
So I guess my question is, we're going to work on this in the working group. So what shall we do? That's my question. So should we consider that? Should we follow the route where we define only one split type value and then we work on the issue of info keyval or info strings, or not?
Yes, the idea is, I would say, perfect, but we have to continue the discussion about the values. It means in principle, with this method, we have the values as strings, and that with strings you can always do the combination of standardized stuff and non-standardized stuff. Whereas when you are using constants, you have a real problem because you cannot check for a constant when it's not there. And therefore I really like it.
So I might have misunderstood what you said, Rolf. But when you say values, you're not referring to split type values. Just one split type value.
Yes, I refer to info values.
Oh, okay.
I like the info values because info values are strings, and strings are more flexible for the case of having standardized and non-standardized values available.
Okay.
So I agree with the info method, but I still not convinced with not standardizing values, and for that I would like to use the use the MPI standard. I would like to share the MPI standard now on the screen. May I substitute the slide by the MPI standard?
Hold on, I can give you the. Oh, you have it. Okay, never mind.
Okay. Oops. What happens? It's coming. It's still working. Oops. Is it doing something?
No.
I'm seeing a blank screen.
Ah, now it happens.
Okay. I'm seeing a black screen.
Okay, a moment, it's coming.
I have a cursor on the mouse. Okay.
Can you see it?
Nope.
You are sharing. You don't see it?
It's black. Everything's black.
It's black.
Are you sharing the application or the desktop?
I'm sharing the application, the Acrobat.
Well, perhaps try sharing the whole desktop. That may help.
Okay, good. I try. Okay, share my screen.
That's better.
That's better?
Yep.
Okay.
Yep.
Good.
Yeah, we're seeing it.
Is the text overlapped with some videos from the other rooms, or can you see only the? No, I expect I must go.
Oh, fine.
Moment.
Hey, looks good.
This I want to show. Okay, and some potentially. That's where I read. Some potentially useful hints info key values are outlined below. The following key values are reserved. An implementation is not required to interpret these key values, but if it does interpret the key values, it must provide the functionality described.
Okay.
And that's what we can do. We can do exactly, we can describe a functionality for a few such info values, and if it's there, if the hardware provides it, then it would work. And at the same time, all HW log values can be provided. And
the issue I have with that is that also, if it does interpret the key value, it must provide the functionality described. What if you ask for a name that is not here anymore? What do? You can't provide the functionality described in that case.
yes, it's allowed not to provide. An implementation is not to require to interpret these key values. Very simple.
Not okay. Okay.
Okay? Very simple. If we provide, for example, if you define level 3 cache and the implementation does not provide a level 3 cache, then it's unused.
The problem remains the same. So we were going to make a list of things. So what if this list grows in the future? We would have to modify this list again in the standard and so on. So it's I don't see how we can solve this issue with that.
It's no problem. You can, in principle, we have the feature. We need not to be fast because the implementation dependent stuff that's fast, okay? But we are still able to add new value names. We are still able to deprecate value names, and we are still able to remove value names. But removal in MPI is always, the rule is the name cannot be reused for another feature. Because when it's reused, then exactly this feature must come back. And that are the rules of MPI, of the two chapters, deprecated and removed features.
So the main problem I see with that approach is, if I remember the discussion in the forum right when we started talking about this, that we could not agree on definitions with the proper name to it. And I don't think we can still do what is a node, what's an L3 cache, or should it be the last level cache? What is if a system has a different cache hierarchy? What's a NUMA domain? If a system has variable NUMA domains, will this change at runtime? I mean, I'm not sure we have enough consensus on these types of hardware that work on any hardware.
Yeah, basically what I wrote on the slide, I said that I wrote that to me, it's very difficult to reach a consensus, as Martin just said, because a name could have a different meaning on different hardware, the same name, or you can have different names for the same thing on different hardware. So it's very difficult. It's very difficult.
Yes, but very difficult does not mean that we should not go this way. Standardization is not cheap. And we must say there are at least 2 other standardization bodies that may have more knowledge about this topic than the MPI Forum. And that's exactly the people who do HWLOC and the people who are doing the OpenMP standard. And both,
HWLOC is not a standard, huh, Rolf?
Yes, but it's still. How many people are working on it? Do they have a definition of what they are doing?
I'm not sure that HWLOC has.
Maybe Brice can answer the question. Brice is with us today, so maybe he can answer the question. He knows.
So I don't think this is a particularly good argument for listing any names in the MPI standard. For a start, I think, Rolf, you've just invalidated your own argument by saying that there are 2 other bodies that know better than we do, right? So us listing the names is a really silly thing to do because there are at least 2 other bodies that know better than we should. They should be the ones that define what these names mean, not us.
Yes. But that's my other proposal. My other proposal is let's take these names and do a clear rule how the names of these others, like OpenMP and HWLOC, how these names are translated into exactly these string values we're providing here. And if you have exactly this rule,
the issue with the HWLOC is that the names are changing all the time. Brice is introducing new names on a regular basis. He's struggling with that. He's going to add a new name in the future, and some names maybe are going to be deprecated. So I think it's a very slippery road to do that.
Okay. I understand your problem.
Perhaps we could satisfy both by if the hardware names function in MPI also gave back the category, a name of the category of where it got that name from, and then we put in a rule, an MPI rule, which is if MPI says that it comes from that category, then it has to abide by the rules of where that, the thing that defines that category is the thing that defines what its behavior is, right? So if MPI says this is an HWLOC name, I don't care what the string is, I don't care, right? I got it out of HWLOC. Then MPI is claiming that it will behave as if, according to the definition that HWLOC gives that name, that string, right? And then HWLOC can change as fast as they like, but MPI can be fixed and say, whatever they've done, whatever they say they're going to do with this string today, that's what we will do, right? That's what we're giving. Otherwise, we won't claim that it comes from that category. It will be some other string, or it won't be in the list. It will be some other category, or it will be not in the list.
Yes. And additionally, it's possible to talk to other bodies defining something. This means we are able to, we did this for Fortran. We really went to the Fortran standardization body, and they said, okay, we are doing this for MPI. And I can also, we can also go to the people who are doing HWLOC and, for example, convince them that when they remove something from the standard, that they really remove it and never never change the meaning of a given name, because that's the only thing that's
No, I
really
think
terrible.
I think that the thing that's imposing a restriction on an external body that's not for us to do. We can ask them to do that, but I don't think we should.
Yes, we can ask them. Yes, that's what I mean. We can ask them.
Well, I'm agreeing with you in that I think we should pose the question. We should ask that question. But even if they say no, we need a valid way forward, right? They are within their rights to say no and do whatever they like. And we should accept that.
Yes, of
and
course.
have a workable solution anyway.
Yes, of course.
Okay, for the record, we have a pretty good interaction with HWLog people because Brice, who's the main developer, is sharing my office.
Good.
So that helps. So I know.
That helps.
Okay, so I know the whole business about names in HWLog. I know how things are working. So that's why I'm very. I think we should be very cautious about that in MPI.
Okay. So I think the issue is more broad than that. I think HWLog is a really good example of it, but I would not want to be trying to tell Intel what a socket means.
Yes, exactly. If
they decide that socket means something else now, which they have done in their past, right? They have come up with new names and they've redefined existing names to mean something else.
Yes, exactly, and that's what the problem Brice has with HWLog currently. So he has to deal with those problems, those issues, and I don't want us to deal with these issues in NPI.
Yes.
So that's my whole point.
Yes.
Yeah.
I'm agreeing with you. So I think that the way to go is to say that MPI will make claims only as categories. If it says that the category is HWLog, then what MPI is claiming by saying that it's that category is that HWLog defines the name. We might then want to return a version string as well as the category, or at least the category might want to include version. It might be HWLog version 3.6 because that's where that name means something, because that's OpenMPI has integrated HWLog version 3.6 into it, so that's where the names are coming from, and it's not HWLog 2.4 where the names meant something else, right?
So then you would need a query routine for the categories too.
Possibly, yes. I mean, we're talking about so the get hardware names thing, the API, the C API that Guillaume gave, is not going to work in MPI because Fortran. We've tried that with sessions. It's going to need to be more complicated. It's going to need to be more like the info object or some other, Like
I had an alternate version of this routine with an info object actually, so I didn't show it, but I have several designs. So once again, the interface is not okay. It's just
I'm not complaining about the interface, Guillaume. I'm just saying that when it's made more complicated, which it will have to be, then we can follow. Hopefully, we can follow one of the existing examples. Either the info object. But that,
yes, sure.
That is a pairwise. That's a tuple of two strings, a key and a value, and so maybe that's enough. Maybe that's a category and a name is one tuple, and so the pairing of a category and a name tells you where that name came from, and so you repeat the category many times as for each of the info keys. The alternative would be the CVARs PVARs type approach.
Maybe I can share quickly something with you. I uploaded a document on the hardware on the working group with the alternate design, and there were a couple of keys that were defined, and then you can query for those keys for the value, and that's changed. So let me maybe. If I can share something.
Yes, what must I do? You are sharing.
I think you have 3 minutes.
Yeah, I know. Okay. Maybe if I want to.
I expect I have stopped sharing.
Yes.
I moved the ball over.
Yeah.
Okay. And while you are doing this, short recommendations. Doing it with an info handle has a problem that we cannot return at the same time the category and the value name. Therefore, I would really recommend to have a routine returning such things. And
so we can we can if the category is the key and the but then I suppose it has to be unique.
I can tell my
key. No, the key when we have 50 different split types, okay? Then in principle, the question is whether we want to do it with 50 info handles, whether we want to do it with one info handle which has as key an index list 1, 2, 3, 4, 5 until 50. But what I recommend is really to go with this MPIX get hardware names or whatever the name should be from this routine, because then we can return 2 strings. But what I would do is I would have a fixed limit how many info keys are supported by an implementation. That can be a real fixed number, a constant, and then the first argument is the index in this array, and then it returns exactly 2 strings, the category and the name, and nothing else. And never do arrays of strings, because this is awful with C, C++, and Fortran.
Yeah, yes. I couldn't share my my document, but the document is on the working group page, and I describe, but it's also a rough design, an alternate way of doing this kind of stuff. So maybe I can try to find this and to refine this design and to send this to you to so that you can see what I'm thinking about that.
Okay.
Yeah, you should look at the CVAR PVAR thing.
Yeah.
That array that returns a whole load of strings, and is probably what you want. But that only has a CO interface, not a Fortran one.
But also, I'm wondering if it's not the right interface to return. It's the same thing. We're talking about categories. There are categories in MPIT. We're talking about names. We're talking about enumerations. All these things have been defined in MPIT.
Okay, so I will definitely take a look at that, because I think it seems to me the right way to go. So okay, okay, thanks.
Cool. So do you have what you need for now?
One question: which is the name of the file?
I'll send an email to you, Rolf.
Okay, good. Because this list here is you don't know how old the files are.
Okay, I'll send an email to you later.
Okay.
Okay.
Thank you. Good.
Okay, thanks.
Thanks.
All right, thanks. So we're at the top of the hour. So it's time to switch topics.
Yeah.
I think the next one was session. So Dan, you're up. I think you were listed in the program as Mr. Session. So
excellent. Yes, I did sort of point that out somewhat time ago, but yeah, I don't mind being sessions today. Right. Okay. So Howard and I have done various things to try and address feedback from the face-to-face meeting. Some of those things are ready to show, and some are not. So most of the stuff that Howard's been doing is the small things that were easy to do, and therefore aren't particularly interesting for this meeting. They'll be shown at the next face-to-face meeting when we do another reading. But they are the simple things where there wasn't really a huge amount of discrepancy or reason in showing it again. So the thing I want to show today hopefully isn't going to take very long, but we'll see. Things always take longer than we think they are going to do. So I need to share. Hello, what's this yellow thing? I don't want that. Preview. Right, so you should be able to see preview the external interfaces chapter of the MPI standard. Perhaps I've lost audio. Can anybody see that?
Yep.
Good.
Yeah, we can see it.
Good,
Yeah.
excellent. So, so this is the MPI 4.0 draft standard, which is why it's got draft written across it.
No,
Chapter 12. Sorry.
no, so I'm not seeing anything, but it's okay. Go ahead.
So some did and some didn't. Some are not seeing. Okay. Well, so I probably can share the whole screen instead if that's going to be.
No, but it's okay. It's okay. Go ahead then.
Right. Okay. So what I'm showing here is what it used to be. I've expanded on the left here the what Chapter 12 used to contain. So we have already moved up to the face-to-face meeting that we just did the reading at. We moved section 12.4.3, the initialization of threads, into Chapter 10, along with everything else that we've moved into Chapter 10, to try and group together all the different ways of initializing MPI. So that would be MPI init was moved from Chapter 8. MPI init thread was moved from this 12.4.3, and it already had dynamic processes in it, and we put the session stuff in there as well, so that all of the different ways of managing processes were in the process creation and management chapter, which made sense to us. So one of the comments from the face-to-face meeting was, what about the rest of this, at least 12.4 section? Doesn't that really go with the initialization subsection? And the answer is, of course, yes, it does. And we sort of not really realized that, or not really thought about it. So one of the things that we've done in the intervening time is to think about what should Chapter 12 look like, and hopefully you can now see what it now looks like. I've changed to a different preview window, and so hopefully you can see now that Chapter 12 is empty. What we've actually done is move the rest of 12.4.3 into Chapter 10, and then that left generalized requests and setting status information. Setting status information is only there because general requests because it's needed for general request functionality. So the MPI threads thing is now in Chapter 10. I've made it a subsection rather than a subsection. I've pushed it above the world process model and the peer-to-peer process model, dynamic process model, in order that it applies to all three. This applies to MPI, not just to any one of the process models. So I think that is correct, and that's one of the questions I want to ask, is does that have implications that I have not thought of? Do we have objections to it applying to throughout, or should it just apply to the world process model? It applies to the dynamic process model as well, or it used to before we started doing sessions. So I think the odd one out is sessions. Should this stuff apply to sessions as well? And I think the answer is probably yes. So before we dive into that too much, the other change that I made is Chapter 9 used to be called the info object. I have renamed it Customizing MPI and made section 9.1 the info object. So the chapter used to only contain the info object, so this section name didn't exist. And then I've thrown generalized requests in there because that is also a way of customizing MPI. It isn't used very often, but it is a way of customizing MPI. That's why it exists. And the associating information with a status section, which is really there for generalized requests, is also a way of customizing MPI, in that you can change the information that MPI would otherwise give in a status. Usually that is set by the thing that you did, the send that you did, or the receive that you did. But here you can actually set different values into the status and therefore make up your own meaning and behavior. So those are ways of customizing MPI. There are possibly others that I've not gone and found, but certainly that's a place to put generalized requests, rather than having two chapters that are very short and have one thing in. It makes sense, I think, to combine these, and then we can get rid of Chapter 12. So Chapter 9 used to be called Miscellaneity. It is in fact called MISC in its tech file name is called MISC still, because it's a miscellaneous stuff that doesn't fit anywhere else. That also describes generalized requests and the setting status information. So I think that that's a controversial change, or at least I hope it is. So that's the sort of what I want to discuss. Really, it shouldn't take very long, or at least I hope it won't, to get your approval of doing those things. So first of all, let's go with the Chapter 9 stuff. Does anybody actually object to renaming Chapter 9 and moving generalized requests and setting status information stuff into the newly renamed Chapter 9?
Yes, it's good.
Okay.
The only question there is this is the right location in the standard, having this customizing in the middle of the whole standard? I'm not sure.
So
Yeah,
that is a good
that's
question.
Yeah, also there's other chapters that might need reordering, because all the things about process creation and management is also in the middle.
So that's the point I was going to make is that's the point I was going to make is the one-sided communications really ought to go nearer where the other communication stuff is defined. At the moment we have point-to-point communication, then data types for some reason, then collective communication. Then one-sided is several chapters away from that. We've got process topologies and environmental management and communication stuff in between. The MPI standard is a bit of a mess in terms of the ordering of chapters. I didn't really want to do that as part of this change, but given that we are making quite big structural changes anyway, we could consider reordering the chapters as part of this. It would make a lot of sense to move chapters 9, 10, probably 8 much later. We could even consider moving chapter 4 quite a lot later as well, because the rest of the interface stands up quite well without data types being defined until quite late. An odd thing you sort of want to define at some point, but maybe not in chapter 4. So yeah, that's a good point. I have not even attempted to try and come up with a good order for the chapters.
Okay, what I would say is, in the moment, the first chapter that uses the info handle is in the moment chapter 8 as far as I can see. But I'm not sure where are the versus, and in the future it will be also, or maybe also process topology. And the other thing is the generalized request that has something they have something to do with requests. And requests are already, non-bugging routines are introduced in the point-to-point chapter. It means I would move exactly the info object to a very early stage.
So I think there are two ways to go there, Rolf. I think there are two places, for example, to put a glossary of terms. One might put it at the beginning of the document so that you know what terms are going to be used in the rest of the document, or you might put it as an appendix at the end so that an interested user can then refer to it as a reference material from the back of the document. I think both are valid ways of structuring a document. In the same way, I think that extraneous information that customizes or changes something that you're currently reading could be put at the beginning or it could be put at the end. I would suggest, therefore, that things like the info object and potentially data types, potentially the environmental management, all of those things should be chapters near the end of the document, because those are advanced features that and things that customize the rest of the interface. You can understand the concept of sending and receiving and collective communication and so on without complicating it with data types and with info keys that adjust things. If you need to know, so the first use of an info key might well be in the collectives chapter, because we've got persistent collectives that take info keys. Do we really want to put it as effectively chapter 1? The first thing in MPI is info objects. The next thing is data types. Oh, and then eventually you get round to doing communication. I think the most important thing in MPI is that it does communication. It's a communication library. I would therefore put the important topics at the beginning and only put the things before it that are absolutely essential for you to understand those, such as the terms and conventions, because you need to know how the document works in order to read it.
Yes,
So that would be sort of my argument. I think that discussion is completely orthogonal to the sessions proposal. It's an interesting discussion. It should probably be had as part of the terms and conventions thing more readily than as part of this. But actually, it's probably a topic for the Architecture Review Board, which we don't have.
Okay.
So apart from moving the chapter in its entirety to somewhere else in the document, does anybody else have comments about making chapter 9 look like this? So Rolf said maybe that generalized requests should be moved to where other requests are defined. I think I object to that on the basis that requests are not just used there. They are also used in persistent and non-blocking collectives, and also in the I/O chapter, and that therefore having requests being used somewhere else in the document is already well established. And
yes, then you misunderstood me. That was only an argument to have this chapter 9 early instead of having it at the end. But you convinced me with your argument it can be at the end, or it can be very late.
So in that case, I'll modify the question back to the simple version of apart from moving the chapter somewhere else in the document, does anybody else have any comments or objections about making chapter 9 look like this, or whichever chapter number it is, customizing MPI as its title, and combining the info object and generalized requests and setting it, associating information with status, combining those into a single chapter and putting it somewhere in the document?
Here, Christoph, I have just a comment. And I was thinking about the MPI error handling. So for me, the customization of MPI would also include setting a custom error handler, for example. So maybe from the naming here, in this case, this came to my association here. So this would be in chapter 8. So it's close, but you have error handler, you customize the behavior. So that's, yeah.
So that is an interesting point. In which case, the majority of chapter 8 would also move into chapter 9, which leaves us with a very short chapter 8, which is implementation information, which is actually, that's an info object. Well, it's a few constants, version and subversion, and then it's environmental inquiries thing, which is attributes, I suppose. There's also the info env object is in here somewhere. And then memory allocation, alloc mem and free mem. Chapter 8 becomes quite short. Maybe we should do something about moving the rest of chapter 8 into other places and get rid of that chapter as well. It's an interesting suggestion. What do other people think about moving error handlers into chapter 9?
I mean, the 8 is also kind of a weird mix of things. So splitting that up and moving to other places seems like at least I haven't looked at the details, but in principle seems like a reasonable approach.
One other thing I just wanted to point out, I think maybe this is, if memory serves correctly or not, but info objects currently serve as kind of a query mechanism as well. And so strictly customizing MPI with info objects at least seems to not necessarily reflect reality today. Now, I know we made some changes to the way info get is supposed to return information. Maybe that's not a problem anymore, but it's something that I'm thinking about.
So yeah, I guess what you're meaning is that without setting any info keys, I might query some of them,
right,
and therefore get more information about what's going on. I think what you're meaning is attributes there. That generally the MPI communicating with the user is generally done through attributes, and querying info object values is really a query mechanism for figuring out whether the setting of info objects
has.
I mean, yeah, I think that's the way we intended it, specifically when we were defining, the new communicator info. But all the stuff in the I/O chapter is, at least at the time, was defined as more of a query mechanism. And
so I would doubt all of it. Yes, certainly some of it. There's at least one. The exception info key is the one about the file name, which is definitely an out parameter.
Yeah.
But the rest of them are things that you can set, like striping value. They're hints definitely, but they are a mechanism for you to suggest you might want to use a striping factor of X, and then you query it to say what striping factor you actually got. Which that was the bit that we clarified was the getting side of that.
Yeah,
but if you haven't set it, I mean, you could still, I guess, query it, even if you hadn't set it. Would you get the right answer? Maybe.
Mm-hmm.
The querying thing was clarified, so I would have to reread that.
Yeah, maybe the clarification we did is strong enough that my point is no longer relevant. But it's just something that I was thinking about when looking at this.
Mm-hmm. I would suggest that isn't given that the other usages of the info object, I would suggest to me that isn't a strong enough reason to say that it isn't used for customizing. It is in some situations. There are some cases where it's actually just used to query, but I think I would still argue for this.
Yeah. Actually, that's really what the introduction of Chapter 8 is saying. Is Chapter 8 discusses routines for getting and where appropriate setting various parameters that relate to the MPI implementation, which is really what we want to do with the info object, is either getting information or query parameters or setting parameters. So it might be best in the Chapter 8.
So are you arguing to move 9.1 into Chapter 8, but leave generalized requests where it is?
It's a possibility. It feels odd to leave generalized request on its own in the customizing MPI. I like the way you've done it. Chapter 9 for customizing MPI is okay. I think the info object belongs there, and it's just that the Chapter 8 is bothering me now that we are starting to move things around.
Mm-hmm. So I think another way of organizing these two would be to move the info object into Chapter 8, because it is about getting and then when appropriate setting parameters, and move the error handling into Chapter 9 because it's customizing, which it doesn't fit in this this introduction to Chapter 8 doesn't cover error handling. Actually, we should remove this sentence. The procedures for entering and leaving MPI execution are also described here. They're not anymore. We've moved them. I didn't realize that sentence was there. So we should move that.
Then error handling has both aspects. One aspect is that the MPI library returns error codes and error classes, or returns error codes, and they are translated then in error classes, and then the application can call MPI abort after doing some I/O. It means that it's absolutely not customizing MPI. It's only customizing MPI when you provide your own error handler, but that's not needed. But it's only part of.
Okay, so in which case, Rolf, we would move the user-defined error handlers into Chapter 9, but we'd leave the built-in ones in somewhere else. I think that would make it really strange. I think if we're going to, for the same reason as the info object is sometimes used for customizing and sometimes used for querying, we have to make a decision about where we put it. I would decide that its primary usage is customizing MPI's behavior. I think that the whole of the error handling thing is customizing MPI's behavior, because MPI generally assumes that there are no such thing as errors. And so if an error happens, you are deviating from the base assumption that MPI makes, that no errors will occur.
My argument would be really to keep it as it was, because the generalized request and the associating information with the status, that was exactly for integrating another application library into the request handle system of MPI, and to have then await all for application and user library based requests. And that's a very special thing. And it was also the reason to have MPI and threads inside of external interfaces, because that was the basis for MPI plus OpenP in principle, or MPI plus pthreads. And if there is a strong reason to move the MPI plus threads into chapter 10, then I would say yes, then it is as it is, but I would not change the rest of the document. This means I would keep the MPI info as a very short chapter, and I would keep the external interface, because that's exactly not customizing, that's really external interface, nothing else. And there's no need to combine info and generalized requests and associating information with status into one chapter of customizing MPI. And we do not know for what we use info in the future. And then again, it would not fit to the chapter name when we use info for other purposes.
Okay, so we have one dissenting opinion then. So yeah, I mean, I guess the only motivation I had originally for combining generalized request into any other chapter was because it makes external interfaces very short if we don't.
That's okay. It's a very special.
So the other option would be. So the other option would be we talked about doing a cleanup for one.
Yes.
We could also just leave the short chapter, since this is actually not really directly connected to the ticket, make a note, and do it when we reorganize more than that.
That's a good idea. Yes. Especially as that's your stated goal for 4.1, is to tidy up the text, and potentially that includes reorganizing things rather than just rewording. Yes.
That was my proposal, but we haven't decided yet.
Yeah. Okay. So that's. I'm not particularly unhappy about that. That's fine. So I can revert the chapter 9 changes and put these two sections back into chapter 12.
Just one thing again, would you be able to keep track of that somehow and start a list somewhere of possible 4.1 tickets? Not put a ticket in, just we start a list somewhere.
So I think the simplest way actually would be to create an issue around that.
Okay.
To do a pull request, or possibly an issue or a pull request or something, because I've done this work already. This particular thing, this may not actually end up being the way it goes, but it's having an issue at least. Excuse me, having an issue at least around that.
And mark it for
an
one.
issue which says reorganize the document so it's in a more logical order, and then a pull request which does just this change.
Okay, let's do it this way then. That sounds good.
Yeah. We never have to merge that pull request, but if we decide to in the future, then it's, when looking through the list of issues and pull requests that are outstanding, we will always rediscover it.
Okay.
Okay, I can do that then. So that then
Thank you.
pulls us back to the MPI threads bit. So this is the section and its subsections that's been moved. So we originally moved the MPI init thread chunk of text so that it came immediately after MPI init. So this is MPI init, and then we've got MPI init thread, which used to be in chapter 12.4.3, 12.4.4, I think. So we moved that before already, and it's as a consequence of doing that, things like what do all these thread levels mean and so on. That all needs to be in here as well. Everything to do with MPI and threads, therefore, should be moved if we're going to move anything at all. It makes sense, I think, to group all of the process creation and management stuff together, or at least I suggested that and the forum agreed. So I think it does make sense to move this section into chapter 10. It is partly, I guess, originally, as Rolf points out, it was an external interface because threads were seen to be external to MPI and not really MPI's bag. It was a way of interacting with things like OpenMP and maybe pthreads and other things that did threads. I think that attitude is potentially changing, and that threads is now seen to be a more integral part. It's certainly affecting some of the implementation considerations in MPI. It isn't just a thing that is tacked on at the end. So I think it does make sense to bring it out of an external interfaces chapter, and it makes sense to add it in here. So I think the only outstanding question to me is whether this is a general, whether the discussion about thread compliant should apply to the sessions, the peer-to-peer process model, whatever we want to call it, as well as the other two. It always used to apply to the other two. I'm not proposing to change that, but should this idea of thread compliant apply to sessions as well?
So if it doesn't apply, you're going to make special comments on thread compliance in the peer-to-peer model?
So that would be the consequence, yes. So in particular, the thing that I was sort of reading some of this as I was moving it to make sure that I was moving the right sort of stuff. And it's this sort of sentence here. In a thread compliant implementation, an MPI process is a process that may be multi-threaded. And so it then says somewhere, yes, in this bit, this model corresponds to a POSIX model of inter-process communication. In fact, the fact that a process is multi-threaded rather than single-threaded does not affect the external interface of this process. MPI implementations in which MPI processes are POSIX threads inside a single POSIX process are not thread compliant by this definition. Indeed, their processes are single-threaded. So this rationale and this sort of introduction and rationale here, it does not exclude things like the MPI library, where MPI processes are indeed threads. It explicitly actually describes such an implementation. It just says that it's not thread compliant. That doesn't mean to say it's not thread safe or any of the other things that might involve the word thread, but it doesn't match MPI's definition of thread compliant.
Yeah. Well, I'm a bit sad about that, but I don't do that.
Right. We had this discussion before.
Yeah.
And so we came to that sort of realization both separately and then in front of the forum, and the forum agreed with it, that this text does not and was never intended to exclude implementations like MPC. And so, we left it alone. We didn't touch this. But I guess my question is, do we want to apply this, which we're not particularly happy with necessarily, or at least not all of us are particularly happy with it. Do we want to apply this to the new way of initializing MPI, which is explicitly going to be more accepting of threads and is supposed to be more future looking? Does this still sit well with us as a group? So I think I'm not particularly surprised by the silence. I think that requires some thought.
Yeah.
It isn't something that one can immediately say yes or no to, unless one already has a predefined agenda and wishes to just push that. I think it's worth raising the point now. We've got quite a few weeks before the reading we've also got another one of these virtual meetings in not very many weeks' time. I think it would be a good idea for, or it'd be very helpful for me in particular, if people could think about whether this makes sense to them now or not, and if not, what does make sense instead. Martin's question about should we make different statements or separate statements about how threads apply in the sessions world is exactly the consequence. If we don't apply this text exactly as it always was, or at least with some modifications, we need to do an editing job throughout this chapter now. But other than sort of minor wordsmithing things to make it read well, if this doesn't apply, then something else must, and we must effectively invent a new way of threads applying to sessions. I'm not averse to doing that, but it will certainly take more time than we've currently got on the MPI4 schedule. I also don't want to just go with this because it's easy and then regret it later and think, yeah, I wish we hadn't done that because now we can't ever change it.
In this case, then I would suggest to send out an explicit question like a week before the next. It's not next week with sessions again, right?
I hope not. No, I think it's the 27th. Something like that.
What I expected, yeah. Let me check. But I think it would be good to send out an explicit question before that so that people actually get an answer on the call, not just silence again.
Yeah. Okay, that makes sense. So I think that's basically all I have for today, Martin. So apart from sending that email, which I can do, or at least I'll draft it now in the rest of this hour.
Yeah, I'm not sure if I would send it right now or a little bit later. This is up to you. But I think having some people think about it before is probably a really good idea because it is a tricky question. Yeah.
Yeah. So I would take this opportunity to remind. In terms of the interaction of sessions and tools, Martin, you said that you had a particular idea about what we should add to the tools chapter. There was a particular place where session needs to be added to a list of objects, and you had a particular idea about what text we might want to put in.
Yeah.
Could you send that to us, to myself and Howard, so that we can incorporate that for the next meeting? That would be very helpful.
It would probably be good to run this by the tools group first. Too, I can see. I think we have a call tomorrow. I can bring this up.
Yes, please.
Okay, I'll take this on. Yeah, we'll do.
Okay. Yeah, unless anybody else has something to do with sessions that they want to bring up in front of everybody, I think we're done for today.
Sounds good. Anybody, anything else? Any other topics you want to touch on? If not, the next meeting is next week, and we're talking about only one topic, we're talking about tolerance, which can easily take 2 hours. All right, and that's nothing but anyone. Thanks, everybody, and talk to you next week.
Bye.
Okay.
Bye-bye.
Thank you.
Thanks.
Thanks.
Next week. Bye.
Bye.